Hello everyone. So I'm doing my final video. It's been really fun. Um, Number one, I needed to create a Linux virtual machine, and I'm going to show the steps and the results of step one, which is create a VM, and then I use the small machine, 2 gigs of RAM, and I use the docker run command to create a container on my new VM. So all this was done on my Google Cloud platform. I named my project Final Project, my last name. I I use the settings when creating a new instance just to make it small and to make it so that it uses less money in the budget. And then here on the Docker, I created a new instance with a Docker run command and the image version that was new. So I'd use this Docker run command to create my database and make sure that um, the SQL agent is activated. Here's the password. So that was that. Next, on two, I move my database into the database that I chosen into my Docker. The database that I chose is the Pokemon database. So I downloaded the backup file and then I uploaded it here. Here is the backup file. So my backup file, once it's here, I made a connection to my SQL Server. Here is my connection as my administrator, and I was able to just restore database from the file. Take some time from home. This is the file that I used to restore. Okay, now gonna restore it again. I will in in the eighth step. But anyways, that was the step that I took. Um, then next, that was step two. I showed my connection and the method that I used to migrate my database. That was my connection that I showed and how I migrated my database with a restore backup file. I created a backup job to back up my database. Gonna show my backup job and prove that all the steps related to job complete successfully. So here on my SQL Server agent, I'm here on this connection, which is my Docker as an administrator. This is other logins that I created. So this is my job, full backup. If I start my job, takes some time. Successful. created a backup file. Okay, next. I create two schemas with data security in consideration. I transfer two tables of my choice to those new schemas, and I granted a select right into one schema to a new user or new login final test user. I will test the login and into the database and prove that I can only see one schema. We'll show the commands that I use to accomplish this. So these are the commands that I use to create the schemas. Then I added these two tables. Each to each schema. And then I created a user, final test user, with this password. And I added this login to, and then I added this user to this login. And then I granted the select permission onto final test user. I'm going to prove that that works. So I have a connection here, final test user. I'm going to close this. So this is the final test user. You can only see the one schema that I granted the select rights to. And here on this query, I already set up this in advance to make it quick. So I can select this table that's on this schema, and I can see it fine. But on this other schema that I created, I don't have permission. If I try to access a table that's outside of either of those schemas, also doesn't allow me to. So my login and user schema security works. Why using schemas is a good security practice? Because it lets you customize what your employees or the users of the database can see. Sometimes some data is sensitive because it can have some sensitive information like social security numbers or credit card information or passwords or anything that can cause any security issue. And using schemas doesn't only secure from being able to see, but also you can set it up so that you cannot delete or update certain schemas to certain users. And that's why it's a good security practice. Next, I created a view that combines data from two tables. One is from the schema that my user has permission, and the other one is from the other schema that my user does not have permission. So the view is in the same schema, yes, and that the user has permission. And then I will grant a select. I granted a select permission to see this view. And now I'm going to prove that this works by logging in and selecting the view. I'm going to show you the commands of how to do this and a quick demonstration. So the commands that I use to create a view is first I created a select statement that joins two tables, one from my schema that my user has permission to see, and the other one is from the other schema that the user doesn't have permission to see. And then I just added the code create view, the name of the view as, and then the select statement. I'm going to show that this works because in this query I have logged in as final test user, as you can see here. And then this is the name of my view which is located in my schema that this user has access to. And I granted the select permission on the object of this view. That's why I'm able to see. So here, if I execute this, I'm able to see the join between these two tables. Using views is a good security practice because if there are some tables that have security or sensitive information in them, but I don't know, a salesperson, for example, needs to see phone numbers to be able to cold call them, then it is important that that salesperson see them. But maybe that salesperson doesn't need to see social security numbers or addresses. So that's why it's a good security practice to tailor and and determine the information that the database users have access to. Number 6, I created a new database role, and this role includes these select permissions. It has access to select the schema from step 4, select from the view that I just showed, and a select on the table that is not inside of any schema that I created on step 4. And I created a list of all these grant commands from steps A through C. And then I created a new login, final running body, and added to this role. I'm going to show you the commands on how to accomplish this step 6. So here, I granted I used this code to create the role. I named it texting, and then I granted the select on the schema to this role testing, and I granted the select on the view to testing, and I granted the select to this random table that the doesn't belong to any of those schemas. And then I used this code to create a login, final running body, and a user final running body with this password. I altered the role testing and I added the final running body. So here I am logged in as final running body. And as you can see, I have access to this schema. I have access to this view, and I have access to this other table that doesn't belong to any of those schemas. This is next. I'm going to show that this column is encrypted. But if you want to see it here in running body, tables should show the schema and this additional table. And views should show the where Pokemon live, the view that I created. So that is that. That's number 6. Using roles is a good security practice because, again, I feel like it's the same as schemas and views. It tailors what kind of information the database user has. Maybe a role, you can create any role where a, a user has access to be able to modify, update some data in some tables. It has able to see is able to see some tables, some other tables not, and doesn't have access to delete. Maybe some roles do have access to delete some other data, so that's good for security, so that not everyone has access to everything. Otherwise, it will be chaos. I set up a column level encryption, and one of the tables that the running body has access to is able to show the encryption and it's working. I'm going to show that. Actually, I already did, but if, for example, I'm going to show that running body doesn't have access to this table. And if I run this query of this table that running body does have access to, table name is encrypted. Okay. For show 8, we're going to show that I can back up and restore the database using the full recovery model. So I deleted this table, the ability flavor text. I'm going to show you in the administration login tables. Ability flavor text is deleted. It's not here anymore. So I'm going to restore it. Using the backup that I created from the job that I ran, that I showed that it's correct. I'm going to override the existing database. I don't need a tail log backup file. And I'm going to close the existing connection to the database so that it can run. Okay. It's going to take a minute. The database was restored successfully. And I should be able to see, if I refresh tables, I should be able to see this table that I deleted or dropped. Ability, flavor. Oh, you know what? I created a restore backup from after I deleted it. So that's why it's not here. But the restore was successful. If I want to restore this, I could restore it from the file that was initially from, but that would delete my schemas. So I'm not gonna do that in this video. Um, Next, I'm gonna show this on another video where I go through my running body in another classmate's information. And then I'm going to answer these questions. What strategies could you explore if the company grows and were asked to create many database copies for testing purposes or future deployments? What strategies? I will say that cloud, the Docker is really good because on the Docker, I can create many instances which can, if I need to create many databases for testing, I can separate them. One is for testing, one is for development, and so on. I think looking into cloud will be will be good if you were to expand and you should weigh the pros and cons of the cost, and yeah, I think using Google Cloud will be a really good idea if you choose to grow. What are some factors or options to consider regarding cloud hosting strategies? Google Cloud is one of them. Amazon Web Services, Microsoft Azure is another one. So yeah, thank you for watching, and thank you for all the teaching for this semester. I appreciate it.